So I will present the results of BeFlexible project. So I'll be quite quickly on BeFlexible. So because BeFlexible is actually ending, so I think you already saw previous presentations from the projects. It will end on August this year, and it's about flexibility, like all the other projects, and it's a 20 partners consortium. So there are DSOs, TSOs, RTOs, service providers, digital service providers. So it's a quite complete consortium on the value chain. And there are 4 conceptual blocks. So one is on the markets and regulations. So the project made the conceptual work in terms of markets, but also implementation of this conceptual work. And I think one of the key things on the project was to simplify local flexibility markets, to make them operational, considering the different regulatory contexts that we have. For example, there was a focus on local energy communities. There is an European directive for energy communities, but then each member state adopted in a different way. So there is a lot of differences when we analyze the local or the national legislation for energy communities. So that's one of the problems. Sometimes we have European directives, and then there are multiple interpretations in each member state of them, and this is a barrier. So that's something we try to address. There was also development of services, energy and cross-sector services, and platforms to enable these services. I will give an example of the grid data and business network, and also on customer engagement and co-creation. There was a lot of work in some of the pilots. And there was 11 pilots, so Italy, Spain, and France, and Sweden. So they were touching different aspects. Italy was also on local energy markets, but also on TSO-DSO coordination. Spain on aggregation of flexibility, operation of the grid, considering long-term flexibility contracts. And then on Sweden, there was also the local flexibility market. So that was actually something common to the 3 projects. I will talk about grid data and business network platform. This was developed on the top of SAP technology. I think Stefan is still here, is there. So if you have any questions on the coffee break, so there is Stefan from the SAP. And this idea of this platform was something to address the full value chain of flexibility. So in fact, we call it a business network because the idea was to create actually a business network between flexibility providers, flexibility owners, investors, DSOs, TSOs, everyone connected through a single platform with interoperability as a key requirement. So we made a lot of work here on interoperability. I think compared to the previous presentation, Saref was also used, but together with the SIM model. So the idea was to have something interoperable with all the agents. And then there was flexibility, capacitation, pre-qualification. So capacitation means that if you have flexibility to offer, or if you need investors to buy batteries, for example, community storage was one of the goals. You have it here on the platform. And there was also the idea to cover this value chain, but also energy and cross-sector services inside this platform. I'll give some examples later, as well as the cash flow and financing was also related with the SAP business. And then, so on the top of the value chain of flexibility, and what you have here is the value chain of flexibility, there was several services that were created on the top of this. I will just address a few services, but some were just to enable flexibility, others were to aggregate flexibility. In our case, our focus was mainly on local energy communities. So this idea was to have these digital services on top of platform that were covering the full value chain. So in the end, this is the full architecture. This is the grid data and business network platform. It was connecting different stakeholders. My presentation will be mainly focused on the platform itself, on the local energy communities in terms of flexibility with one service, which is recreation, and also on grid segmentation as covering the DSO side, and how a DSO can create these grid areas so that flexibility offers can be procured. This is just an example of the grid data and business network. So allows DSO to create areas for procuring the flexibility. Those areas can come from the grid segmentation, as I will show an example later. And it also allows the bidding process, so the flexibility service providers to present their bids in the platform. And also for activation of flexibility, as well as for aggregators to see how many flexibility was activated and historical data. The intention here is to have one platform for multiple DSOs. So this follows what was being done in United Kingdom with Flexible Power Platform, and also with the initiative in Spain with 4 DSOs that was called SIORD, but SIORD was just for data exchange. So this is like an upgrade on the top of SIORD, where it considers the full value chain of flexibility, including activation of flexibility. And it was designed to be interoperable with local flexibility market platforms. In our case, we use the one from OMIE in Spain, but this could be interoperable with other platforms. Okay, and then there is this grid segmentation for flexibility. That was a concept we developed in the project, and the concept was intended to help the flexibility procurement. So in our concept, we have a local flexibility platform. This is operated by the market, by a market operator. In our case, in our pilot in Spain, was operated by OMIE. So OMIE have a platform for local flexibility market. It's still a prototype. It's not fully in production, but it's being used in pilots and sandboxes. So there is actually at least one sandbox in Spain for flexibility, local flexibility markets. The grid data and business network was the connection with the DSOs or multiple DSOs and with aggregators, and also with the platform. So was not competing with the market platform, was actually augmenting this market platform and adding new functions on the top of it. And on the top of this, we wanted to have these zones to buy flexibility and procure flexibility. And those zones, they should be connected and attached with technical problems on the grid. So if there is a technical problem, we have a database of zones where the flexibility should be procured in the short term and also in the long term. I will not enter too much into details, but those zones, they are calculated with a power flow calculation and with sensitivity indices. So on the top of sensitivity indices extracted from the power flow analytical sensitivity indices, we can build zones where the flexibility is activated within those zones, have a similar impact on the technical problem, in this case on the congestion or voltage problem. So it means that an aggregator can procure within those zones any flexibility provided. The impact will be quite similar within the tolerance, of course. So, and this is an example. So if we have several lines or several feeders on a substation, we have some that might get an overload. For the technical problem, we can build multiple flexibility zones and areas. So each zone here, so each consumer on this area will have a similar impact independently from the node where you are on that technical problem. So this allows a DSO to do a segmentation of their grid, to procure flexibility where is needed, and also an aggregator to know where they should procure and engage flexibility providers. So that was the whole idea. We can control the zones according to the tolerance and the error within the zone. So in this case, we have 23, but in fact, we could be less. This could work with 5 zones, but depends on the tolerance we're willing to have. And then for each zone, there is a total maximum flexibility that is needed by the DSO, and this is what goes to the procurement phase. So that's the idea. This was made with real networks in Spain. And the idea is to do this segmentation so that the procurement is easier and it's scalable for an aggregator. Okay, and then we worked on this community aggregation level. So the idea was to use this platform for local energy communities, considering flexibility. So there was a platform. This is now a commercial platform. So during the project, we started as a prototype. And during the project, together with SAP, we created a commercial product. So this is, I would say, it's almost in the phase of going commercial on the top of SAP Cloud. And we have planning of communities, operation of communities with energy management system, transactions, when there is peer-to-peer transactions, and also the settlement. And this, of course, it's modular. So for some communities, we might have planning or not, for example. That's an example of the dashboard, that it's available for the community members, for the community manager, and for the aggregator. And this is an example on how it works. So we have the OMIE platform with the DSO. On the top of this, we have the grid data and business network because it's used for flexibility activation and also for settlement. So we have aggregators that can offer flexibility, but we can also have local energy communities with this platform offering flexibility as well. So it's flexibility from the community, and the platform can also be interconnected with the grid data and business network. So that's the whole concept, and everything was done on the top of SAP Cloud, and it's integrated with the SAP technology. The reason for this is that this is quite fast to deploy in any DSO and in any community, and the fact we have interoperability, this can actually work with multiple DSOs and multiple energy communities in the single platform. Going to the demo, so we have a demo in Spain with 20 residential consumers. The objective was to size the community, so the assets of the community, and also to optimize the operation of that community. This was not just peer-to-peer trading. On the top of this, there was the local flexibility market, and we need to consider that the participation in local flexibility market, it might be profitable or not. That's one thing that on the sizing we have to consider, but also on the operation. So there are different stages, and so when we do the planning on sizing the resources without considering flexibility on the first stage. Then on the second stage, we consider flexibility as an add-on on the top of the resources. So and how this influences the sizing of the community. As you will see, if we size a community with and without flexibility, this will influence immediately, in particular, the OPEX, but will influence the resources that we can have because the return on investment will be different. So that's one thing on the sizing and planning of the community. This is just an illustration of the results. If we don't consider flexibility, we don't actually need, or having batteries on those consumers are not interesting. And this is something you will see later for the whole consumers, is that if there is no flexibility provision, the incentive to have more PV and having more battery is lower, but more than that, most of the income comes from self-consumption and not from flexibility provision. So as a community, your main benefit is more on the PV and sharing the PV and not so much on flexibility provision. So in this case, if we have flexibility there, we'll get a reduction on the TOTEX, and you will see that there is now an incentive to have batteries on those consumers. Okay, so that was the initial idea. Then there is operation of the community. So we need to calculate first the baseline. So again, without considering flexibility. So this is the baseline. And then on the top of the baseline, we have to construct a flexibility bid of offering flexibility for different prices. But we don't know the market price in advance. So in the end, we have to construct a bidding curve where for each price of flexibility, we have an amount of flexibility. So higher the price, higher is the amount of flexibility that is available. And those bidding curves, they are constructed for each community and considering all the resources. I didn't mention this here, but something with this market analysis we made and the regulation, something we do is post-delivery settlement. So we do a settlement only with the measured values. And the idea is to simplify the way the settlement is done, which is particularly important for flexibility. Otherwise, it would become too much difficult to do it. Although the baseline comes from stage one, we always need a baseline for flexibility provision. So results from the pilot and the summary results. So when we're considering sizing, so on the planning side, these are the main conclusions we extract from those 20 consumers in Spain. So one is that what is attractive, so PV is attractive, but most of the income comes from the self-consumption. You'll see this later with the flexibility. When we start having the flexibility participation, we have to consider another thing, is that there are assets, we call it here cross-sectors assets because of electrical mobility, but we have batteries, we have a competitor, electrical mobilities and electric water heaters that are storage that is already on the customers. So if those assets become available, their flexibility replaces the batteries. So at a certain point, batteries are no longer interested if we have flexibility from EVs and electric water heaters. So that's one thing to consider. So with this integration of flexibility, we see that the payback period reduces substantially, which is also somehow expected. And the net present value increases. Of course, higher the flexibility price, higher the profit, and more interesting from the economic point of view it is. Okay, and then it's the thing on planning. Then when we consider the operation of the community itself, we see that the more flexibility does not increase, for example, the cost savings. And the fact for this is that most of the income can be or results from the self-consumption savings and not so much from the flexibility savings. Of course, there is an increase when you have flexibility, but more flexibility you have, stable it becomes. Okay, so that's one thing to consider when we start investing in batteries, if there is already electric water heaters and electric vehicles there. There is also emission savings from flexibility. That's also quite relevant. And we see this small increase. So the impact of flexibility is not so much on the operational domain, is more on the, not so much on the OPEX, is more on the CAPEX, which influence, of course, the TOTEX. Okay, and then if we consider not batteries, but electric vehicles and electric water heaters, there is a low entrance cost on flexibility markets compared to batteries, which is also relevant. Okay, and then to conclude my presentation, so the Grid Data and Business Network is a cloud-based solution, and it's quite easy to onboard the new assets and new flexibility, so it benefits for being a cloud-based solution. Energy communities, they can be an actual aggregator. Within the community, it needs to rethink, we have to rethink the settlement. It needs to be simple for the members of the community. So one thing we proposed in BeFlexible was this post-delivery settlement, simplify things, in particular for the members of the community, and this is the most important actor here, because if we don't have the members, there is no community, no flexibility from the community. The grid segmentation also enables the scale, so it allows an aggregator to know exactly where to procure. They know that those consumers within that area, they have the same impact, so they can treat them equally in terms of impact, so this makes a little bit easier the job of aggregator, but also of the DSO, because they know exactly where the flexibility needs to be procured for that specific problem on the grid. This is quite relevant for long-term congestion management. Was something in the Spanish pilot, it was tested, because they have to procure flexibility for the long term. So know where to procure that flexibility for a congestion that will stay there on the network for 1 or 2 years. It's also a challenge, and segmentation simplifies the process. And that's all. Thank you.
Thank you very much. Do we have any questions from the audience?
Hi, you mentioned very briefly in the end that one of your conclusions was that the agreements within the community members could be simplified. Can you say a bit more about that exactly? And do you have any publications where you explain a little bit more the details?
Yes, we have a publication just on post-delivery contracts. It means it's relevant within the community. So imagine a community, this is the opposite case of what we have, a community where you as a consumer, you have to predict your consumption, you have to optimize day ahead your consumption, you may have to make a bid inside the community of your flexibility and everything. For you, it will be super complex if you have to do this on a daily basis. So this is related with something was discussed, I think, in the morning presentations, how you keep them continuously engaged on the community. Of course, you could say we do this automatically and this is no longer a problem. It is, because you have forecast errors, you have deviations. From forecast errors, you have losses, and this is a big problem. What we propose is that we do everything with measured values, post-delivery. So the community aggregator, you have to do the forecast, you have to do the optimization, but then when you divide the benefits by the community members, you divide them based on measurements. And this is a way of simplifying this. Although some of these community members, you have to control their assets if you offer flexibility. So you need to think in a different way of how you distribute these benefits by those members of the communities that are more active than the others. So there are two publications actually on them. One just for energy, so peer-to-peer settlement with post-delivery. Another one more complex for flexibility provision, considering that some of them are more active than others. But that's a goal, because if we start with this daily negotiation within the community, we'll lose community members quite quickly, in my opinion.
So one of the things, if I understand correctly, so you are making this is a DSO is managing most of the things inside this network. So DSO is deciding how much value is added and how much value is being, let's say, transferred. They may save some of the assets and so, but they decide how much is the value of the flexibility, right?
Not necessarily. I mean, in this case, they are procuring a quantity, not at the price. Depends on the time horizon. If we are considering short-term, so there is in the Spanish pilot, short-term and long-term congestion management. Short-term, they don't define a price for it. So you basically, you get offers, you might use or not, considering how critical is the problem and so on. Long-term, yes. So in long-term, you have a budget. And the budget comes from not reinforcing a certain network area, for example. So the budget gives you the cap, the maximum you are willing to pay for flexibility. So you launch a tender, knowing that how much budget you have to buy on flexibility. So in the long term, the answer to your question is yes. You put some kind, I would not say you put the price, maximum price, but you put a maximum budget, which can be a price together with a maximum amount of flexibility. This is what they do in the UK. So this platform was based on the flexible power platform in the UK. So in the UK, it's a regulator, actually. The regulator Ofgem in the UK, they have an Excel sheet. You put there how much you are deferral investment on the grid, and then you can calculate the budget you have to spend on flexibility. And then it's up to the DSO to procure flexibility within that budget. I think this is something in Europe we should also think, because in the end, flexibility might not be the best option compared to network reinforcement, depending in which grid area you are, for example.
Okay, thank you. The second question is that basically, so the DSO is managing the activity in its own network. Mm-hmm. So that means that this flexibility is bound to certain DSO. So it actually owns it in his pocket. So there's no free auction, or they cannot sell it anywhere else.
No, it depends on the, well, if we think on DSO level, yes. So it's quite local. So in general, you have that flexibility for one DSO, because the impact is local. We are talking about congestion and voltage. But it's not, when we think DSO, TSO, no. We are considering here that both can procure the same flexibility, and they can, I would say, coordinate activation of this flexibility. This was not tested in Spain. My presentation was mainly on the Spanish pilot, but was made in Italy. So in Italy, there was a traffic light system between DSO and TSO. So it's common, and it's a challenge. Between DSOs, it's quite uncommon if we consider they have the concession of a certain area in the grid. But you might have cases, it's not the case on these countries, because we are talking, the project have big DSOs. There are countries who have a DSO on medium voltage, another one on low voltage. And that is a different story. And we didn't consider that in these models, but this could happen in other countries. I think in Finland, you might have these situations. In those countries, it's not so common, because we are talking about big DSOs.
Yes, so in Finland, it is like that we have got these grid operators, and then we have got this sales, or let's say sales organization that's only selling through some networks. So that's divided, like the transfer fee is divided from the energy bill. And that makes it is complicated, because the congestion problem is entirely on the grid management side, and then the DSOs, they don't care about that actually at all. So it's like a problem is somehow not. It's more complicated there.
Yeah, I think this is the order of priority is important, because I think the problems will occur first in low voltage grids. So they should have the priority. Because a DSO with a problem on the low voltage grid, he can only solve it with the flexibility on that grid, independently from the medium voltage DSO, because he can find other solutions. If he doesn't have, he needs to invest on the grid or something. So I think priority to low voltage grid and flexibility should be higher. But we didn't have this problem on the consortium, but it exists, and it's a big problem, actually.
I totally agree. Thank you.
Thank you.
There's one more question.
Yes, I was curious to know from one of your first slides, how the DSO is forecasting the congestions of the grid?
Yeah, there depends.
Sorry, I imagine it is a sort of forecasting of the demand before, and then to understand how the forecasted demand has an impact on the congestions.
Depends on the time horizon. So in the case of Italy, Areti have used Sonho, which is an open ADMS with forecasting capability together with the port flow. The same with NL, but NL use their own ADMS, already have this capability. In the case of Spain, there are 2 time horizons, short term, so short term was the same approach, but the long term was from the planning team. So they were integrating explicitly flexibility as an option on the planning and comparing how much they spend with the flexibility with reinforcing the network, building a new line or upgrading a new line. And that was more use of a planning tool with forecasts you normally use on the planning with load growth and those kind of things, which is actually, in the end, you don't avoid building the line, you just postpone it. If we consider load is growing in a certain area and you have a congestion because of that, use flexibility just to avoid building it now, but you have to build it 2 or 3 years from now. It will happen if load will grow.
Actually, I have one question from myself. Maybe to confuse the situation even more, at least in Czech Republic, the community is typically related with municipality. So this is kind of the driver who can establish the community itself, and it's much less about the operation. And then I hear like a lot of about DSO, which is a bit like in Czech is typically, and I think it's Austria as well. It's like you are using allocation keys, and it's kind of billing transaction rather than really trading. So how you think we can use this local energy market, and who should be the operator of that? Is it like DSO or municipality itself, or what is your opinion on that?
It should be the municipality. Those cases are occurring in Europe in multiple countries. I mean, they don't own the network, right, in Czech Republic?
No.
Okay. No. So in this case, it should be the municipality. Of course, here, if we consider the aggregation flexibility, municipality will act as an aggregator itself. But the idea of the European directive, if we read it, the first directive for the renewable energy communities, it's intentionally driven for non-profit associations, and the second one as well, although the second one consider ownership of grid, which is another story. So they should be non-profit. So it makes all the sense to be the municipality. We didn't address this here, but mitigation of energy poverty, that's also a mission for the local energy communities, and they can play a very important role on that. So it makes all the sense. I can tell you in Porto, the municipality created an energy agency just to manage the local energy communities of the social neighborhoods on the municipality.
Okay, so I wanted to confirm maybe that, because it's as well in my view.